Students, we'll continue the explanation of code snippets on pointer structures and unions. So in the main, I have a character array which is initialized to RBCE CSE, and I have a if statement here. I have printf %s a equal to 7. It means that the printf, as we know, that it gives the number of characters which are printed, and in this case a contains the RBCE CSE, which is 7 characters. So this condition becomes true. So you will be executing the if part, which is printf success, and it returns 0. So the output will be RBCE CSE will be printed by using printf %s, and since it prints 7 characters, so after that success will be printed. So let us check this output by executing on the online compiler. So suppose if you run, you can observe you will be getting RBCE CSE success. Suppose you have forgot and you have printed left out one blank space here. So then the number of characters printed will be 1 blank followed by 7. So this condition becomes a fail, and you will be getting the RBCE CSE followed by failure. So let us execute and check that. So you will get RBCE CSE failure. Now if I make use, now suppose I print f %10s, then 10 spaces will be allocated. Again the 7 will be failed, this condition becomes failed. So RBCE CSE with the 3 blanks towards the left, and failure will be printed. So run it and check. Now suppose if I write %-10s, then you can observe 10 positions will be reserved for printing RBCE CSE, but the string is left justified. So 3 blanks will be printed after RBCE CSE, and since this condition becomes failed, you will get the output as RBCE CSE followed by 3 blanks followed by failure. So run it and check. So you can see that RBCE CSE followed by 3 blanks and failure will be printed. Next one, inside the main I have character ARR initialized to hello world, and I have a pointer, character pointer, which holds the address of this ARR, which is a string. If I have the expression ++*ptr, it evaluates as first a dereferences. So *ptr will be giving h, and that will be incremented. So h will be incremented by 1 to get I. So when you print %c *ptr, I will be printed. So now in this I have a separate increment or expression and then *ptr. So if I combine, again I am going to get the same answer. Next is character array, again the initialized with the hello world, and char *ptr equals to ARR. Now in the printf %c ++*ptr will be printing the value as I, which we have seen already. Now if I use printf %yes *ptr, now your h was replaced by l, and it will be printing LELLO world. So the output will be I, and since I have a new line, so it goes to the next line and prints LELLO world. Now the right side, I have the same ARR which is initialized to hello world, and I have a pointer, character pointer, initialized with the address of the ARR. Now the first printf %c *ptr++. Now this *ptr++, it evaluates like first it dereferences the ptr, so it will be printing h, and it increments the pointer to point to the next character, where here it is e. So now the printf %yes ptr will be printing starting from e onwards until a null character. So ELLO word will be printed in the next line. So let us execute this code and check the output. Now suppose if I write plus plus star plus plus at the beginning, then it has to first fetch the content increment. So it will be printing from the first one, it has to print I and then ELLO. So I and then it will be printing IELLO world. Next, on the structures. Suppose I have a structure declaration like structure opening bracket, members are integer I, float F, and the name of the structure is variable is var, and inside the main I have var dot I equals to 5 and var dot F equals to 9.767. So I am printing printf %d percentage dot to F var dot I var dot F. You can observe the members of the structure can be accessed by using the structure variable name followed by the member name. So %d for variable dot I will be printing the value of I, which is 5, and percentage dot to F prints the value of F belonging to the variable var. Here in this case I require 2 decimal places, so the number 9.72767 will be rounded to 2 decimal places, which becomes 9.77. So 9.77 will be printed. And the next here I have character array, which is again initialized to hello world. Character star ptr equals to ARR. And the printf %c star plus plus ptr will be executed as first. Ptr will be referring to the character, h will be incremented to point to the address of E. So when you dereference, you will be printing E from this first printf statement. So the next printf statement will be %s ptr will be printing the character from the current position of ptr, which is from E onwards until a null character. So ELLO world will be printed. Next, here I have a type def structure containing the members integer I, float f, and the name of the structure I'll be declaring is by the var. So inside the main I have static val equals to flower bracket 555, which will be initialized for integer I and 67.05501 for the F. Now printf %2d percentage dot to F val dot I val dot F will be printing 555, because here %2d refers to the minimum width. So here the minimum the width of I is 3, so which is greater than 2. So all 3 digits will be printed. And here the same as the previous, the val dot F will be rounded off to 2 decimal places. So the value printed will be 67.06, since the digit after 2 digits, which is 5, is greater than or equal to 5. So it will be rounded off to 0.06. The next here the same structure, but here I have a structure containing the member I and float F, and this is just a structure declaration, will not allocate any variable or space for any structure variable. It is just a template. And inside the main I have integer I equals to 5 and float F equals to 9.677. So printf %d dot to F will be printing the values of this I and F, which are the variables which are inside the main. So it will not be printing the values which are inside the structure. So it will be printing 5 and 9.77. Next is on the union. So union integer I, float F, var. So var is a template with the members I or f. And inside the main, I have var dot I equals to 5 and var dot f equals to minus 9.767. So since I am first initializing the integer value with 5 and then f with minus 9.767, so the I will be overwritten and f value will be retained. So the I value, you will be getting a garbage value and the value of f will be retained, and since I am using 0.2 with the plus, so the sign will be printed and 2 decimal the value will be rounded. So we'll be getting some garbage value with minus 9.77. So the same union, if I initialize with this format, that is after union int I float f, close the union with the variable equals to 5, 9.767, and if you use the same printf, you can observe that the first value will be retained and the second value will not be initialized. This will be printing 5 followed by the garbage value. Thank you.